Okay, welcome back. So we are going to take the last of the questions on the Center Regional Mock exams proposed by a student on our YouTube channel. So this is the E part and the F part of the question. Okay, so if you are not subscribed to our channel, please do subscribe for more of such contents. And for those who have not watched the first and the second part of these videos, the link will be dropped in the description. So let's get started with the video. So what do we have? In a race, a cyclist is moving up a slope that has constant gradient. It takes 8.0 seconds to climb the slope. The variation with time t of the speed of the cyclist is shown in figure 4. That's the figure which is shown. Okay. Determine the total distance moved up by the slope. The bicycle and cyclist have a combined mass of 92 kg. The vertical height through which the cyclist moves is 1.3. For the movement of the bicycle and cyclist between t equals 0 and t equals 8, calculate the change in kinetic energy. Okay. Lastly, calculate the change in gravitational potential energy. The cyclist pedals continuously so that the useful power delivered by the bicycle is 75 watts. Calculate the useful work done by the cyclist climbing up the slope. Then F is on Doppler effect. So let's begin by analyzing the question keenly. Now, what do we have? The graph here is not really clear. So what we'll do is we are going to go to our PDF reader. I'll try to zoom it there so that we try to see what is really happening, because the graph here is really flu. I don't know, my eyes are not seeing that clear, so we are just going to see how to get it the right way, and so that we can be able to calculate the area under that curve, since distance is the area under the graph. So let's pass to our PDF reader. Okay, so this is what we have. I tried to read these things, so we'll really do our best. Our result might not be accurate, but the most important thing that you have to know is the methodology, because the squares are not even divided, so it's really difficult for the counting to be done. So I try to split this 0, 1, 2, 3, 4, 5. So that should be 1, 1, 2, 3, 4, 5. That should be 2, 1, 2, 3, 4, 5. That should be 3. Now to calculate the area, this area, we have to calculate the total number of complete squares plus half the number of incomplete squares. Then we have to know the area of 1. So what would the area of 1 be? So here we have the area of one box will simply be side times side or length times width. So when we check here, this is 0, 2, so it means midway will be 1. So it is in intervals of 0, 1, 2, 0, 1, 2 on both sides. So the area of 1 will simply be 1 times 1, which is equivalent to 1 meter. So that's one box. Now we have to know the total number of boxes that we can find here. So we have things like this probably, and yeah, so it's really complex. Okay, so we see that all these boxes here are complete. So I can say we have 1, 2, 3, 4, 5, 6, 7, 8 complete boxes, 8 complete boxes, 8 complete boxes 3 times, 8 complete boxes 4 times. So that's already about 32. Let's note it there. Now here we see we have this box not complete, this not complete, this not complete. Let me really mark it well so that we'll come and count the incomplete later on. Let me use a good ink. No, let's use something like this. Okay, so that's the problem when the graph paper is not clear. So we have 1, this second one is incomplete, we are here, so it means 2 are incomplete in this row, so that will be, since there are 8, so minus 2, that will be plus a certain 6. Then up we have this incomplete, we still have about 6 complete plus another 6. This incomplete, I don't know if you are seeing, but for me, I'm really doing my best to see. So here we have this. Here I think I have 2 incomplete too, so maybe plus, or let's go back there, let's say plus another 6. Then now let's fall here, 1 2 3 complete, 3 incomplete, so I have 3 incomplete here, so plus a certain 3. Then no incomplete, so 1 2 3 plus 3 incomplete again. Okay, now for this incomplete we have total number of incompletes. I hope it's right. So here we have 8, that's 8 plus 8 16 plus 8 24. So here should be 24, not 32. Oh, okay, 32. So oh, I don't know my problem with 32. 24 plus, okay, we assume that the rest are correct, so but that's just the methodology. So how many incompletes do we have here? We have 3. So this 6 incomplete, 7 8 9 10 11 12, so there's about 12 incomplete, and the total number of squares will be number of complete. That's 6 plus 6 12 plus 6 18, so this is about 40, plus half the number of incomplete, 6 plus 6 12 divided by that 6, so we have about 46. So to minimize our errors, we'll surely use 40. So we can use 40 times 1, which will give us 40 meters. But the reason why I really want us to reduce errors is because we can clearly see that as yourself you can see that things are not moving. I'm not seeing the graph clearly, so we are going to bear that. Let's just assume the whole number 40. So normally if it means that if with this rough estimate we have 40, it means if we calculate it well, we can be between 40 to 50. So let's just take 40 to really minimize our errors. Now let's go back to our slides. Okay, so we have seen that the distance is 30, or we said 40 times 1, 40 meters. Okay, now the bicycle and cyclists have a combined mass of 92 kilogram, and the vertical height through which the cyclist moves, the vertical height through which the cyclist moves is 1.3. Now for the movement of the bicycle and the cyclist when t equals 0 and t equals 8, calculate the change in kinetic energy. So what's really going to be the change in kinetic energy? Now let's go when time is equal to, let's say at time t, when t is equal to 0. So when t is equal to 0, what do we have? 6 meters per second. Now when t is equal to 8, what do we have? We extrapolate here, should be 3 2 3 1 2 3 4 5, yes, exactly 3. Okay, so that's what we have. So what will be the change in kinetic energy? The change in kinetic energy will simply be a half m into v squared minus u squared. Is that okay? So what do we have? So this will simply be equal to a half m into, we have 6 square minus 3 square. This is going to give us a half m into 36 minus 9, and our mass is 92. So that's 92 on 2. 36 minus 9 is 27. So this will be 27. Now let's punch. So it's about 1242 joules. That's what we have as answer. Now the next, calculate the change in the gravitational potential energy. So what's PE? So the gravitational potential energy is simply equal to mgh. So what's our mass? 92 times 9.8. What's the height? Move the height of 1.3 meters. So 1.3. So this be 92 times 9.8 times 1.3 is 1172.08 joules. That's what we have. Then Roman 4. The cyclist pedals continuously so that the useful power delivered by the bicycle is 75 watts. Calculate the useful work done by the cyclist in climbing the slope. So what's finally the useful work done? We know that since the rate at which the work is done, which is the power, is W on T, it means W will simply be equal to PT, and the power day is 75 watts. The duration of all his journey was 8 seconds. So that will be times 8 seconds. So that will be 75 times 8. That's 600, which will be 600 joules. Okay. Now the next. A man, that's F. A man standing next to a stationary train hears a frequency of 400 Hz emitted from the train's horn. Then the train then moves directly away from the man and sounds its horn when the speed is 50 meters per second. The speed of sound in air is 340 meters per second. What is the difference in the frequency of the sound heard by the man in the two occasions? So what do we have? We have the first case. So we have to calculate, we have the initial frequency, or that's the frequency of the horn, which is F0. Now what is our case? The man or the train is moving away from the man, so it means it is a case of source moving away from observer. So I'm going to solve it here. So what do we know? F will be equal to, what do we know? It is C plus or minus U0 divided by C plus or minus US. All of this times F0. Okay, now so this is the speed of the source and this is the speed of the observer. Now what happens? What we know is in our case, our observer, how we see, he is stationary. So if he is stationary, it means that his speed, the speed of the observer, is 0. Now if the man or if the source is moving away from the observer, what do we think the apparent frequency F prime will look like? It's definitely going to decrease, and if this is supposed to decrease, it means what is on the denominator here should increase, so it cannot be negative. So F prime will simply be C divided by C plus US, all of these times F0. So what do we have? F prime will be equal to 340 divided by 340 plus 50, all of these times F0, which is 400. So what will be the result? So this means F prime, he has to reduce 340 divided by 340 plus 50, that's 390. 340 divided by 390 is 0.87 times 400. So we have about 348.72 hertz. Now let's calculate the bit frequency. So we are looking for delta F. So the change in frequency, delta F. So delta FB. So delta F will simply be F minus F prime, and that will be 400 minus 348.72. So we have, that will be 51.28 hertz. So that brings us to the end of this video. Thanks for watching, and see you in our next video.